Here we are in section 5-3, exercises 1 through 4, and we are factoring. And here it says factor by pulling out the greatest common factor. Number 1, is there anything common among these three things? No x's are common here, but there is, let me see, a 3 goes into each one of them. So we'd pull out a 3 and we would have x squared minus 4x plus 11. There we go. All right, number 2. Is there anything common amongst all of these? They all have an a in them. They all have, looks like a squared is the maximum we can get that's in all of them. What about numbers? Let me see. There's a 2. A 4. 4 goes into all of these. So we could pull out a 4a squared. And we're left with 1 minus 2a. If we take an a squared out of an a cubed, we get a 2a, and then plus 4a. 2 plus 2 would be a 4, minus 5. A 2 plus 3 would be a 5. So when we pull out 2 a's, we're left with 3 of them. Now, if you had pulled out a 2 to begin with, then you would notice that what was left still has a common factor, and we need to pull out the greatest common factor, so you need to pull out that one as well, and eventually you'll end up pulling out a complete 4a squared. All right, number 3. You'll notice here that this term and this term both have a p plus 8 in both places. So we pull that guy out, p plus 8, and what's left is this one and that one. So what's left is a 2m plus a 5. Oh, that's pretty cool. Look at that. We pulled out an entire binomial that was found in a bunch of different places. Number 4. Look at this. We have one term here. We have a t minus 4 there, a t minus 4 there, and a t minus 4 there. If we pull out a t minus 4 and undistribute that, what parts are left? We have an x squared left, a plus 3x left, and a plus 5. So what's left is the x squared plus the 3x plus the 5. And yeah, that's what we did. We took those t minus 4s and just pulled them all out of the whole thing, like undistributing.